ladies and gentlemen, happy to see you back. And today we're talking about two-step inequalities. But of course, first we would like to revise one-step inequalities, how we do that, what are the hidden problems, and so on. So we can see in front of us on the screen one-step inequalities generated by that beautiful site which I always use, maths8.com. And let us begin with the first one. Here the letter is unusual, it's J, but it doesn't matter, we have to isolate that letter. How do I do that? Of course, I add 5 to both sides of the inequality. I will be using the space to the right as my scratch paper. And by the way, maybe scratch below. Yeah, I will be using the space below it as my scratch paper. So to isolate J, I have to add 5 to both sides of my inequality. And then here, positive 5 and negative 5, they just cancel. And here is my answer. J is less than 9. This is it. I got not only the solution of my one-step inequality, but also a set builder notation. This is the answer exactly in set builder notation. So when we solve our inequalities directly, we get the answer in a set builder notation. What do we have to do? They ask us to graph. Okay, all right. But first of all, I'll write interval notation. The interval notation answer would be the following. I understand that J is less than 9. It means that J stretches to negative infinity. It means that my starting point on the left is negative infinity. And I remember that I don't include it. It's not closed. It's never closed, because infinity actually it's an idea which is not so easy to grasp actually, and it's not a number, so we can't include it. And here I have to write the right end of my interval. It's 9, but I see that I don't include it either. That's it. That's interval notation. And now all which is left is to graph. That I easily do by drawing a circle around 9 and doing this. I might also do this, but as you see it takes more time, so just the first thing is nice. Okay, let us do number 2. I have to isolate G, and to do that I have to add 3. G minus 3 plus 3 is less than negative 8 plus 3. G cancels, and I have to calculate negative 8 plus 3. It is obviously negative 5. This is my set builder notation answer. G is less than negative 5. Interval notation, like in the first example, is negative infinity, negative 5. I was going to forget the sign, which is not advisable, negative 5. And that's it. I don't include it either. It's less than. And then I just draw it, graph it. Okay, number 3. Here we have the first problem. I have to isolate Q, and I see a coefficient and I see a negative coefficient. In this case, I remember when I isolated by dividing by negative 5, I have to change the sign, change the direction of my sign, flip the sign, whatever. So negative 45 over negative 5, and I change the sign because I've just divided by a negative number. Negative 5 cancels, of course. Here, negative 45 divided by negative 5 is the sign of positive, it's 9. We have 9 is less than q. Usually we write it in another form, q is greater than positive 9. We reverse the inequality and this would be our final answer. But for the purposes of interval notation, this one is more acceptable for writing an interval notation. I understand that I stretch my interval, not me, stretches to positive infinity. It means that I have to start with 9 and I have to include it because the sign is greater than or equal to. So I include 9, I close my interval, and then on the side of positive infinity it's not closed, like that. And the last thing is to graph it. To graph it, I have to blacken it sufficiently so that a strict teacher wouldn't say, oh no, this is not included because you didn't blacken it enough. Oh, okay, all right, I've done it enough. Okay, then I skipped some numbers because I was not going to solve the whole sheet, worksheet, just number 6, so 4 and 5 are missing. Number 6, we've seen such things before. It's just we add, I'll do it fast, we add 3 to both sides of inequality. 3 cancels, and voila, that is it. I have 8 is less than w. Actually, we rewrite it, usually we rewrite it as 8 is greater than w. But both forms are acceptable. And finally, set build notation, good, interval notation. And this gives us, starting from 8 to positive infinity, always, or both sides are open, and to graph it, I do like that. Well, number 7 is the same. Okay, let's do it. For the sake of integrity. To isolate x, and for the sake of the name of the variable, because x is actually the first time we found x, we have something exotic. So, x, to isolate x, I have to subtract 5 from both sides of the inequality. So 5 minus 5 plus x is less than negative 13 and minus 5. And here 5 cancels, we have x is less than negative 18. That is it. The solution is obtained, and all I have to do is to write interval notation. It is from negative infinity to negative 18, and it is closed. And then I take negative 18, blacken it sufficiently, and drew it like that. Well, I'll have to do it again because my interval has died out here. And the last one is worth mentioning because here we have again division, but unlike number 3, in which we've divided by a negative number, here we divide by a positive number, and there is no difference with equations, absolutely the same, we don't change the sign. So for b over 4, to isolate b, is less than negative 48 over 4. Here 4 cancels, b is less than or equal to, what is it? It is negative 12. Negative 12, which is the result of division of negative 48 by 4. Great, that's our set build notation. And our interval notation would be obtained by writing this. It's from negative infinity, of course it's not included, not closed, never closed, to negative 12, which is closed, which is included. So when graphing it, I blacken sufficiently, and then with my shaky hand I graph it to the negative infinity. Now we come to solving two-step inequalities. Actually, the procedure is pretty much the same. We don't do anything different. Just in the first part, where we encountered only one-step inequalities, we had either to subtract or add, or to divide or multiply. But here we do both. Okay, let's begin with number one. Here we have to isolate negative 2r's. To do that, I subtract 4 from both sides. 4 minus 2r. 4 cancels. And I think it's a good idea to calculate. 14 minus 4 gives me 10. So I rewrite my inequality like that. That's the result of my first step. And the second step, as you understand, is to divide by negative 2. Again, we have to remember, this is the only thing to remember when we solve inequalities. The only thing to remember about and remind ourselves that it is the only difference if we compare the process of solving inequalities and equations. So when we divide, we have to change our sign, flip it. 10 over negative 2 is greater than negative 2r over negative 2. And negative 2 cancels. On the right side, left side, I have a tendency of mixing right and left. We have 10 divided by negative 2. It's we know that the sign is negative, and it's just negative 5. Negative 5 is greater than r. So it's a good idea to rewrite it like that. R is less than or equal to negative 5. Here I didn't change the sign, I just changed the sides, so to speak, and in this case, you know, where that pointed thing shows it's to R, it should be left like that. So this is my already my builder set notation, set builder notation. So, and the interval notation is negative infinity, negative 5, closed. And here we have, when graphing, an obvious thing. Alrighty, almighty. Now, what do we have here? First, we have to remove this 6. Okay, alright, let's go. Negative 14 minus 6 is less than or equal to 6 minus 6 plus 5p. 6 cancels here, and we have negative 20 is less than or equal to 5p. Here we don't have to worry about changing the sign, because positive 5 is positive. It can't disguise itself into being negative. We can see mathematics is open. Sometimes we have, of course, something when something is disguised in word problems or somewhere else in difficult problems, but not here. Here nobody is cheating on us. So 5, positive 5 is positive, so to speak. So we divide negative 20 by positive 5 and don't change the sign. 5p, positive 5, it cancels. And negative 20 divided by 5 is negative 4. So negative 4 is less than or equal to p. Well, it is the answer. We can rewrite it as p is greater than negative 4. But the first form is more convenient for us to write down the interval notation, because we have to start from negative 4 and stretch up to positive infinity, because there is no other limit. And we have to include negative 4. So, oh, and wow, this is my first mistake, noted. Negative 4, of course, yeah, I just, here, that's it. When I was blackening positive 4 instead of negative 4, I thought to myself, wow, they made it nearly at the end of the number line. Why is that positioning? But then I understood that I was going to blunder. Okay, so here again I'll do it a little bit faster. I have to isolate negative 3, negative 3v, negative 3v of course, plus 2 minus 2 is less than 20 minus 2 minus 3v is less than 18. Then I divide by minus 3v by minus 3, and here I change the sign. 18 negative 3, because I divided by a negative quantity. So what we have is v is greater than negative 6. Negative 6. Let me, for a change, first graph it. Negative 6, it gives me this. It looks like they wanted to mislead me, because negative 6 is just to the right, and actually it's greater than. Then I have to be careful. And interval notation gives me, I start with negative 6 not including it, and I stretch right to positive infinity. Alright, number 4. Here, for the first time, we'll have to multiply, but first we have to isolate s over 6. To do that, we have to subtract 2 from both sides. 2 minus 2 plus s over 6, 2 cancels. That gives me 8 is greater than s over 6. To isolate s and to obtain the final answer, I have to multiply by 6 to cancel this 6. So 8, it was supposed to be 8. I was thinking about 6 already. 8 multiplied by 6 is greater than s over 6, and multiplied by 6. So 6 cancels. 48 is greater than 6, than s. And s, we can rewrite it as s is less than 48. But it's not necessary, we can leave it like that. And then just to graph it, I do it like that. And to write an interval notation, I go from negative infinity to 48, and I don't include it. In number 5, again, we encounter a negative coefficient next to our variable. So it means that we'll have to change the sign. But first we have to isolate it. Negative 3b plus 2 minus 2 is less than negative 31 minus 2. Here it cancels. We have negative 3 very close. I could, let me do it here. Negative 3b is less than, it's negative 33. And then I divide negative 3b over negative 3. Here I have to, I was too fast. I controlled myself. I have to change the sign because I am dividing by a negative quantity. And here negative 3 cancels, but negative 33 divided by negative 3 gives me just 11. B is greater than 11. That is it. That's my answer. And to write here an interval notation, I have to just start with 11, not including it, into my interval, and to stretch to positive infinity. So here it is. Okay, so in number 6 we'll have to multiply again because we see k over 5. But first of all we have to isolate. Negative 5 minus 2 is greater than 2 minus 2 plus k over 5. Here k cancels. Negative 7 is greater than k over 5. We multiply by positive 5, so we don't change the sign. It's negative 7 by 5 greater than k over 5 by 5. It cancels. So negative 35 is greater than k. We can say that k, rewrite it as k is less than negative 35. And here is my interval notation. It goes like that. Negative infinity, negative 35, and I don't include it. And I don't include it. So where is negative 35? Aha, here it is. Oops. Here, that sound, oops, actually it's not in Russia. We say this when it's like there. Alright, there we go. Here we have to divide. We'll have to divide by 6, which I'm looking at the coefficient at y. But first we have to isolate 6y by subtracting 3 from both sides. 27 minus 3 is greater than 6y plus 3 minus 3. It cancels here. And 24 is greater than 6y. Then we divide. 24 over 6 is greater than 6y over 6. It cancels. 4 is greater than 4 is greater than 4 is correct. It was supposed to be y. Here it's y. And I can also rewrite it as y is less than 4 in the other. Because if 4 is greater than y, then y is less than 4. But this is suitable for interval notation. I have to include 4, and then I have to go to positive infinity. So it will look like that. Number 8. First we have to isolate g over 3 by adding, in this case, minus 4 plus g over 3 is greater than 7 plus 4. Here we cancel, which gives us g over 3 is greater than 11. And then we have to multiply by 3, and we don't change the sign because plus 3 is positive, positive 3 is positive. G over 3 times 3 is greater than 11 times positive 3. Here it cancels. G is greater than 33. Graphing this would be easy. just this. And interval notation starts with 33, which we don't include, which we indicate by this round parenthesis, and plus positive infinitive, which is also not included, again round parenthesis. Here in number 9, first we isolate h over 6 by adding the same quantity as we have to remove. Minus 3 plus h over 6 is greater than 9 plus 3. Here it cancels. All which is unwanted cancels. We have left this over greater than 9 plus 3, it gives us 12. And now we have to multiply. Again, we multiply by positive 6, so we don't change the sign. H over 6 multiplied by 6 is greater than 12 by 6. Here it cancels. H is greater than. How do I mentally multiply? It isn't included in multiplication table. I will multiply first 6 by 10, which gives me 60, and then 6 by 2, which gives me 12. It's 72. 72, and this is it. My interval notation would be starting from 72 and increasing it to plus infinity. Infinity is a little bit crooked, but it will do. And here we go like that. And the last one, but not the least. This is again isolation, division, or multiplication. Isolation means that we subtract 4 from both sides. Plus 5c is less than negative 36 minus 4. Here 4 cancels, and here we have 5c is less than minus 40, negative 40. And then we divide by a positive quantity, so we don't change the sign. Negative 40 over 5. Here 5 cancels. We have c is less than 8. Negative 8. Was going to make another mistake, but of course your concentration sometimes slips, falters, whatever. You lose your concentration, but it shouldn't. You have to control when you divide anyway. And here the sign is of course negative. So this is already a set builder notation. To get an interval notation, I just write this. Negative 8 I don't include, and when I graph it I put a circle around negative 8, and here it goes. Well, I hope you understand perfectly what to do, so you can generate more worksheets with this beautiful aid and practice, because we all know that practice makes perfect, and which I wish you to achieve. Perfection in everything you do. Okay, hope to see you again.